Hey guys, welcome back. This is Ostris. Today we're going to be taking a look at Wan 2.2. This model came out about 2 days ago, and it came in 3 different variants. So we have there's the larger ones that are the 14 billion parameter. These work like a mixture of experts. So it's kind of like SDXL. So the first part of the noise, the high noise part, has one model, and then there's a whole separate 14 billion parameter model for the last part, or the low noise part. So, and for that, they have 2 different versions. They have the text to video, so you can just type your prompt, get a video, and they also have image to video. But both of these on the 14 billion, it basically comes out where you need 28 billion parameters loaded, although you could unload them halfway through the image, but it takes time. But still amazing. And then the one that we're going to focus on today that came out is the 5 billion parameter. I'm super excited about this. When Wan 2.1 came out, they had a 1.3 billion parameter model. It was pretty good, but it also, I was hoping for a little more. And they really nailed it on the 5 billion parameter. So this one, I'm most excited about this. The other two, they're cool, mixture of experts. It's going to be great for making video. You're trying to do the best thing you can. For training, what I'm most excited about is this 5 billion parameter model. Here's why. One, it doesn't have the mixture of experts. So it only has one model. You don't have to have 2 different models that you have to train. On the 14 billion parameter, I don't have support for it yet. I'm going to add it. But on that one, you're going to have both models, and you're going to have a separate LoRA for each model being trained, depending on what noise step you're on. So it gets a little more complicated. On this 5 billion parameter, we don't have that. The other thing is, you see here, it's not just T to V or I to V. It's TI to V. So this one can do straight text to video or image to video. And the way that they set this to work is completely different than the way the image to video worked previously. Previously, on the 2.1 image to video that they had for the 14 billion parameter, it had to have an image encoder, so you'd use like Clip Vision. They actually used OpenClip for it. And it would encode the image down and have that as an auxiliary input, kind of like your text embeddings. And then it would also still have a whole nother layer for an extra frame to go on that stacks inside your input. But on this one, what they did is they did away with the vision encoder. So now every single frame being generated through the model, it has it where every single one has its own denoise level. So when you're denoising an image, you start at high noise and you walk it down, and you have to tell the model what level of noise you're at. Well, on this one, every single step has its own denoise. So all we're telling it is the first image, that one's completely denoised, and the other ones we iterate through as we're denoising. And that's super exciting because you should be able to do in frame, middle frame, anywhere in there. You could do continuous sliding windows, all kinds of cool stuff. I mean, we're just now scratching the surface. I think this 5 billion parameter model is going to be a huge deal that we're just now starting to see. I'm going to show you guys how to do image to video today. So what we're going to do is we have to have videos, and we're going to extract the first frame of the video, and that will be our start frame. So that's going to be our image we put in. And then we have the rest of the video. So that's what we're going to do today on Wan, text to image 2V, and of course we're going to be training on AI Toolkit. I'm going to head over to RunPod. You can do this one locally. Another great thing about this model, it has 16x compression. Normally the latent space is only 8. This is 16x down. So it's a 16th the size of the image. And it also does 4 compression on the frames. So every 4 frames gets compressed into 1 latent frame. It makes it where it's super fast to generate, takes up low VRAM. It's an amazing model. And training it is fast. Generating it is fast. I just love it. I love it. Absolutely love it. I'm going to come on RunPod, do a 5090. I've trained this already. I did all my tests on a 4090, so 24 gigs is fine on this model. Let's come over here. We'll do AI Toolkit UI official. Let's edit the template. Let's see. Got to set our password. I go through this in every single video. If you need more explanation, go to an earlier video. That's ready to go. I'm going to deploy it. It's deployed. We can come here now, click connect, HTTP service here, and we are live. Access token, this is our password that we entered when we were setting it up in the environment variables. If you didn't set one, it's just password. Okay, let's go to our data set. I've already prepped a data set. Some important things on data set. You want to set your data set up so it's a certain amount of time. You have to go ahead and clip the clips. For clipping my videos, I typically use KDEN Live. This is open source software. You can go download it. I'll post a link in the description. This makes it real easy. You can come in here, clip the videos, whatever. But you can also use, any video editing software. For Wan, what we're going to want to do is we want to clip these videos down to about 5 seconds. The original Wan was actually at 16 frames a second. This one is doing 24 frames a second. It can do about 5 seconds of videos like that. So about 121 frames comes out to about 5 seconds of video. So come in here, trim your videos up. That's how I do it. I already have all these trimmed because I don't want to make you sit through all of that. Let's take a look. What are we training today, guys? Do you know yet? Do you know? Let's see. Let's put mystery. It's a mystery data set for now until we upload it. We're going to add images. This can also be videos, and I have videos prepared. Just going to take those, drop those in. Sometimes this upload bar will hang at 100%. I'm trying to solve that, but yeah, if you see it hang, just wait. It means it's still uploading. I don't know the complications of counting, it gets rough. Videos are uploaded. Let's see, what is this? Let's click a little button here. Let's look at this Thomas the Train. And this is what we're training. Hydraulic crush videos. So I've gone through, I've scraped a bunch of different videos. All these are hydraulic crush videos. So I tried to do it where the actual crushing mechanism is outside the frame. I couldn't get it that way on all of them, but on most of them I have it that way. So that way when it comes into crush, because we want to be able to put images in that, don't have a crush arm at top. So if we can do it without that, that's ideal. So all these videos, yeah, crush. They're all about, some of them are 8 seconds, some are 5. I just did it how long it took to crush. If it's longer, it's going to shrink them down to your frame count. So it doesn't matter if it's a little longer, a little shorter. You just don't want to upload like a 20-minute video here because it'll evenly space the frames when it pulls them. So yeah, that wouldn't work. So here's a 20-second one. It's longer, but you can tell this comes down slow. So when it's training, it'll just go a lot faster when it comes down for the crush. So this is what we're training on. Hydraulic crush, image to video, LoRA. Let's get it going. We will come over here to new job. And let's create a new job. So we're just going to put this as crush it. Crush it. And then I'll put Wan 2.2. Let's just do 5 billion. Try to avoid periods, spaces, stuff like that in the names. Just generally a good naming convention like that. So with these, we didn't caption. You probably noticed that. We're just going to use a trigger word here. You can click on that, read how trigger word works. We're just going to put crush it. So all these videos is just going to have the text, crush it. Model configuration, click on this, going to scroll all the way to the bottom. Wan 2.2, text image to video 5 billion. Perfect. On this one, it does start with low VRAM. I recommend leaving low VRAM on no matter how much VRAM you have. The reason for this is low VRAM will make it, when it generates, it's going to unload every component when you're not using it. So it'll encode the text and then unload it. And then it'll load up the model, run the model, and then it'll unload that, and then it'll load the VE, decode the VE, and then it'll unload that. The reason for this is, since this goes down 16x, they actually trained an enormous decoder on the VE. It's significantly larger than most VEs, so it takes up a lot more VRAM. So during training, we're not decoding. We're not generating the images. We're only encoding them. But when we are sampling, we are decoding, and it'll a lot, or it'll overload the amount of VRAM you have. So it's on by default. When you select this model, leave it on. Leave all the quantizations the same. We're on a 5090 right now, but again, you can do this on 24 gigs because this model is highly efficient. It's awesome. Batch size of 1, 3000. All this is good. Learning rate, 180 -4. We are going to unload the text encoder. Since we're going to use a trigger word, crush it, for every image, there's no point in encoding the caption every single time because our trigger words crush it. You have to have a trigger word though if you're going to unload, because it'll encode this first and then it uses the trigger word for the caption of every single image. But since we're doing that, we'll unload the text encoder. Our data set, mystery, which it's not a mystery anymore. And we don't need 1024. It's too much. On 4090 or 24 gigs of VRAM, you should be able to get by with both of these. In fact, I am training one right now off the scene that is doing at 768, 512. These are both great resolutions. I mean, you can train one probably up to this. I don't know what the VRAM takes. I haven't tried it yet. So that's all perfect. And we'll come down to our samples. Now, it went ahead and the defaults for this model is going to be a width and height of 768. I know these samples will work with the settings I'm showing you at 24 gig. Exactly like this. This will work. So we're going to be doing 24 frames a second, 121 frames. This comes out to around 5 seconds. So you can see 121 frames, divide that by 24 frames a second, it's around 5 seconds. And that's why on our video, we did 5 seconds for every single one. And that's why we're also in our data set. I missed this in the data set. This is important. Images. We are going to match our number frames. Okay, so we're doing 121 frames a second on samples. We're doing 121 frames on the data set. So this will be 5 seconds, 121 frames. Evenly spaces them when it pulls it. On this model, it's going to automatically pull your first frame, and that's going to be your control frame, your start image to video frame. I already prepared some images here. We'll delete these. I have 3. So this is we're gonna be doing video, but Wan does it quicker. On video, it's a lot faster. If you've watched my other videos when we've trained a video model, you know that I try to do 1, maybe 2 here. I'm gonna do 3. When you're doing it at home, I've been doing 2 just to have, at least more than 1 sample. But we need to update this to crush it, because that's our trigger word. Crush it, crush it, crush it. And then we're going to add some control images. So let's do the first one. Okay, so for number 1, we want to crush a hamburger. Second image, we are going to crush a Cybertruck. Pull that up so you can see it. It's kind of a little bigger than the frame, but Cybertruck. And for the third image, just to see what happens, a guy sitting on a park bench. I have no idea what's going to happen when we crush a person. Hopefully it's not super gruesome where I have to remove it from the video. I don't think it's going to be though, because obviously we don't have any human beings being crushed in our data set. So I think it's just going to be a bunch of plastic parts firing out, or he'll look like Play-Doh, or nothing will happen. I have no idea. You're going to do this with me. So we have our prompt, crush it, crush it, crush it. 3 videos. Each one we're doing 21 frames. We're doing 24 frames a second, or a total of 5 seconds here. We're going to leave everything else the same. On our data set, the important things, number frames, 121. If you're doing images, set this to 1, because that's 1 frame, single image. 121 for video. That's perfect. That's 4 or 5 second video roughly on Wan. 2.2. We're going to do 512, 768, and then we have our trigger word crush it, and we are unloading the text encoder. That's all we need to do. We're going to leave our LoRA rank at 32. We're good. Let's create the job. It's ready to go. We're on our RTX 5090. Hit play. It's going to generate our samples first after it downloads the models the first time. And let's see what we get on samples for the very first set. We're doing our samples right now. We're on step 11. But look at our VRAM. 12.6 gigabytes of VRAM during generating. And we are doing 121 frames. If you tried to do 81 frames on even the 1.2 model, it's substantially slower than this. 4 seconds in iteration. This is super fast, like way, way faster than the 1.3 of Wan 2.1. So it's awesome, and it's using significantly less VRAM. I love this model. I love the Wan 2.2 series in general, but the 5 billion parameter model, it's amazing. First one's done. Let's go look. Does it know how to crush it? It knows how to put some really gross fingers on top. Okay, it's like it's crushing garlic on top. I think that's, I don't know. It's definitely not doing a drill press crush. So that's good. We're going to teach it how to do that though. Okay, all the samples are done. It is training. Let's take a look at the VRAM right now. So remember, we are training at 512 and 768, and we're training for a full 121 frames. I mean, this is what it was trained to do. This will give us 5 seconds of video, and we are at 22.2 gigabytes of VRAM. Now that's with the text encoder unloaded. So this will totally fit on a 24 gig card. Training at full frames at 768 by 768. We are averaging about 5.5 seconds in iteration now. If you're familiar with 7.26 now. So it's going back and forth between the smaller resolution and the bigger one. But if you are familiar with training on like a Flux LoRA, that's probably the most common that everyone's been doing for the past few months. For a Flux LoRA, you're averaging about probably 2-3 seconds, somewhere around there when training at full resolution. And since we're doing 121 frames as opposed to 1, this is super fast for a video model. Like, I'm blown away with how much I love the Wan 2.2 series. Let's go look at our samples that we have. Okay, no one's being crushed. We'll focus on one at a time. So the Cybertruck, I have no idea what that thing's supposed to be. Okay, I guess your typical Cybertruck owners walking by. And then on this one we have, he's crushing it, I guess. Our first training samples are in. This is at 250 steps that it's done. Let's click on it. Wait for these to load. It takes a second because they're videos. Okay. One at a time, the burger. It's breaking down the burger a little more, which it should do when it, explodes. This person's starting to break into pieces. So we are definitely going into a trajectory that we want. So I think this is good. It's going to take a little bit to train it because we're only at step 250 right now. But this is looking pretty good so far. So I'm going to let it run. You know the drill. All right, so right now we are on step 500. You can see the samples here at step 500. It's not crushing. So I realized something. I'm going to go ahead and stop it. You can stop and restart at any time. So it's kind of good this is happening so you guys can see how it works. Okay, and then once it's stopped, you'll get where you can click edit. We're going to edit this. One thing for image to video, time step type. Put this on weighted. You could also do shift that's fine. Really, any of these will work. Sigmoid's good for characters if you're training on one image. But for anything else, probably weighted, shift, or linear. I'm going to use weighted. It's basically linear time steps or uniform time steps, but each time step is weighted for its impact on the model. This is going to speed things along substantially. So when you're setting it up, use weighted here. I'm going to update the job. And then we can click play. And I'm probably going to go ahead and update these defaults as well. So that way it's just weighted by default. So by the time you see this, it's probably going to be weighted and you don't have to do anything. We are at step 1500. Let's see what we have now. Scroll to the bottom here. Everything's crumbling, but we're not getting the piston coming down. I mean, it's just kind of changing up the frames a little bit, but it's not actually doing what we want. So let's try a new tact. I'm going to go ahead and pause it or stop it. Let's go up to edit. Okay, I'm going to show you guys how to hit this a little harder. And this may just be good to do for image to video anyway, since we're trying to change the overall composition, right? Especially on this, we want that piston coming down. And it's not doing it, and this might help. We don't ever talk about this in my videos, but there's this little feature called time step bias. And when you click on this, you can see that it says balanced, high noise, and low noise. We're going to do it on high noise. When an image is being just denoised, or a video in this case, the very first time steps are the highest time steps, but the highest noise time steps. This is where the whole composition of the image or video is being put together. Normally we do it balanced, so this just makes it even across the entire, where it's high noise, low noise, whatever. And that's generally really good. On this, we're having trouble changing that composition in our images. So since we want to have something completely new happen that the model doesn't know, where the entire frame is going to shift, we're going to switch this to high noise. I think this is all we need to do. We could bump the learning rate as well. I'm not going to do that. I am going to go ahead and bump the steps to 5,000 since we're halfway done now. So yeah, time step bias, high noise. That way we're going to affect the overall composition. It will still do later time steps, but it's a lot less frequent. It has a heavy bias on all the high noise time steps. Let's just update that job. And let's start it back up. And we're going to see if we get a little more, because you can tell. I mean, stuff is like crashing. I mean, it's like shattering like it does in our data set, but there's no piston. Where's the piston? The piston needs to be coming down, and we don't have a single instance of the piston coming down. The burger's stretching and doing some stuff, but the composition of the hands coming into the frame, you see how the hands come in here? The composition's not changing. What's happening is changing a little bit, but yeah, so we're going to hit that composition with a giant sledgehammer. And I bet this solves our problem. Okay, 250 steps later, samples are done. Let's see what we got. Come on, give us a hydraulic press. Here we go, here we go, here we go. Okay, well, we have this pressing all the way through the floor and through the table. Okay, early time steps. That's what we need. High noise. Awesome. So now we just let it go. It's cool how the hand is still coming in, like the hand's pushing it down. That's great. The other ones don't have it yet, but man, the effect has gone quite a bit more. So hopefully that hydraulic press comes in these other two. Feeling a lot more confident now than I was an hour ago. All right, we are at step 3000. Let's take a look at these samples. Scroll on down. The burger is just looking great. I mean, everything about this is perfect. I love it. These other ones are having some issues. And as we scroll up, you can see the burger's been doing a drill press for a while, for a very long while. The other ones haven't even attempted to do the drill press yet. We are getting some stuff, you know, it's almost like the drill press is coming down and squishing, but there's no hydraulic press. I keep calling it a drill press. Sorry. The hydraulic press is coming down. So I think we're good. I think we're done here. And one of the reasons I think this is going on, let's go look at our data set real quick. Every single thing in here has a platform. You see the platform at the bottom of all of these. And so I think the burger one, because of stuff like this, the model knows what is in this world here, right? So it knows this is a big car and it knows this is a guy on a bench. If we put something that actually could be put inside of a hydraulic press, like the hamburger, it knows what to do with this. This car on the road, it doesn't know what to do, or this guy on the bench. So I'm going to stop it here. I think we're good. We can get into comfy. We can throw some other things at it and see how it works. But I'm feeling good about it at this point. Now, you may be wondering, you may have seen this picture before. I use it in a lot of samples. This is actually my dad when he was in high school. And I love this picture of him back in the 70s. So I use it frequently. I don't know if he knows this or not, but I do. So let's give this a run. Let's see if it actually crushes. Okay, what do we have? It's not being pressed. Okay, so let's try this. We're going to try the banana. So what I'm thinking is it knows you can't crush the head. It understands the physics of stuff. This banana on a table, it's kind of like our hamburger on a table. It kind of matches the drill press items on a drill press. In the actual physical world, you could actually place a banana on a drill press. On a hydraulic press. I'm deeply sorry. I've said drill press this entire thing. Let's give that a run. I bet this one works. Yep. Kind of. The background's changing. Okay, we're going to take a drink on a table. It should be able to crush that too with a hydraulic press. I got hydraulic right that time. Let's see. Yep. I mean, I don't know if... let me rephrase this. I know for sure that's not how a glass cup would actually break. But it has the hydraulic press cup again. I'm feeling a lot better about it. So it has to be something that can actually be crushed, which is crushing to me because I was really hoping to put people's faces in this. I guess that's not going to happen. So I'm just going to have to put my demented side to the side for now. Let's give it another shot. Let's check out this gumball machine. And we have another one. Let's see. Hydraulic press, do it. Yes. Oh, it's beautiful. Absolutely beautiful. Yes. Oh, that's great. Okay, so what we've learned is if something can actually go into a hydraulic press and be crushed, it works 100% of the time. If it can't, the model knows this, and it doesn't work 100% of the time. However, I'm going to get this to crush a person. I have scoured the internet, or Pexels, because I need to be able to use the images. I found one. We're going to give it a shot. This one. Now, white background, person sitting on the ground. There's some flowers in front of them, maybe to trick the model into thinking you're just crushing some flowers. That's what you have to do. You have to trick it because it's a super ethical AI. No, it just will not crush a person. I guess that's good, but I'm not done yet. No. Well, no. Okay, we're going to try one last thing. What if it's like a person? This is very similar. It's a Funko Pop, but it's a person Funko Pop. Let's run that. Okay, did the Funko Pop work? Yes. So we have created a model that will crush things with a hydraulic press if they're crushable with a hydraulic press, and it will 100% refuse to crush things that are not. So I guess we can all sleep soundly knowing that our AI overlords will refuse to crush us with a hydraulic press at least. So that's how you can train your own Wan 2.2 5 billion parameter image to video LoRA. I hope this is helpful. Be sure to like and subscribe to the channel if you enjoyed this video and got anything out of it. I hope it helps. But if you want to support me even more, you can go to ostrus.com/support. And on here, you can support me on Patreon, GitHub sponsors, PayPal. Look at all these beautiful people that are currently my supporters. All of these people are what make making videos like this even possible. I deeply appreciate all of you so much, more than I can ever express. But that's it, guys. Hope that's helpful, and I will see you next time. Okay, let's just do a little thing here. Okay, we're just going to take this one we know works. We're going to come in, adjust that, fill. Okay. Then we're going to take this guy, and come in here and just select him. Okay, and then we're just going to paste him right there. Then we'll just drop him in right there. Hit run. Okay, just give that a little shot. We go again. Okay, we'll just go ahead and move him right there, like that. And then we'll just do a little something. Like, ooh, what's this? Is that a hydraulic press? Looks like it. Just go ahead and put that right there. Okay, just put that there. And just, it worked.